Hi everyone, this is the second video for section 8.3 on multiplying and dividing integers. So in the last video, we talked about multiplying integers where one of the factors was positive. And we could pretty much just use the things we had talked about in the chapter 3 on whole numbers. We could use those same models for thinking through when one of the factors was positive. But now we want to consider the case where both of the factors are negative. So how do we multiply two negative numbers together? So we know, because we've all passed college algebra, that when we multiply -2 and -3, that the negatives will cancel. But why does that work the way we want it to? So you can think about this in a few different ways. So the first way we're going to consider is a sign model. So whenever we had one positive factor, we had that, for example, when we were dealing with something like 2 times -3. And whenever we were dealing with 2 times -3, we were dealing with adding two groups of three negatives. And so, or equivalently, we were combining two groups of three negatives. But now, when we add a negative here in front of the 2, now we can think of this, instead of combining two groups of three negatives, as removing two groups of three negatives, right? Combining is the opposite of removing, right? You either add things to something or you take them away. And those are opposite operations, just like how plus and minus are opposite signs. So we want to think of -2 times -3 as removing two groups of three negatives rather than adding two groups of three negatives. Okay, so we start with 0 pairs because we're removing two groups of three negatives, but what are we removing them from? Well, you're really removing them from 0. So you can think of this as sort of a subtraction from 0. So what we do first is we start with 0 pairs. And what we do with those 0 pairs, so we make however many of them so that we can remove two groups of three negatives. So because I know that if we're moving two groups of three, that means we're removing 6 total. I'm going to go ahead and write down 6 0 pairs. So we start with our 0 pairs, and then we remove two groups of three negatives. So this is actually doing the operation, right? We can think of -2 times -3 as removing two groups of three negatives. So when we do that, we find one group of three negatives, and then we find another group of three negatives, and we remove both of these from our model. And then, as always, our last step is find the value of the remaining signs. So right, our last step in any model is to just find what the value is. So we're left with 6 positives. So that tells us that -2 times -3 is +6. Okay, and this is how you use a sign model to do it. So you start with 0 pairs because you're removing from 0, and then you're removing two groups of three negatives, which gives you 6 positives left over, and that is your answer. Okay, so we can use this sign model to do it, but we can also use a pattern. So most everything that people find about math comes from a pattern. We can use patterns to show that a negative times a negative gives us a positive by starting with a multiplication fact that we already know or that we can show in some way. So we're going to slowly alter this equation, 2 times -3 is -6, to try and find a pattern. So we know that 2 times 3 is -6 using the strategies that we talked about in the last video. So the strategies from page 1 or the previous video, where we could think of this as two groups of 3 negatives gives us 6 negatives. Okay, so we're going to slowly change this, like I said. So instead of 2 times -3, now we're going to look at 1 times -3. And again, we know using the strategies or the page from the page before, or because 1 is the multiplicative identity, that 1 times -3 is -3. So how did we get from the first line to the second line? Well, we decreased one of our factors by 1. So we're keeping our factor of -3 the same, but we decreased our factor of 2 to be a factor of 1. And then what happened with our product? Our product increased by 3. Okay, so now let's decrease our factor by 1 again. So if we went from 2 to 1, now we're going to go down to 0. And when we look at 0, we know that 0 times -3 is 0. Again, using the strategies from before, but also because we have the 0 product property, right? That just tells us that anything times 0 is 0. So again, we decreased one of our factors by 1, and you can see again, our product increased by 3. And so now we've established a pattern. So what can we say now? Well, we can say that if we decrease our factor again by 1 to get -1 times -3, that our product should also increase by 3 again and give us +3. So again, decreasing our factor by 1 increases our product by 3. And this one just follows from the pattern. And lastly, we do our pattern one more time to see that if we decrease a factor by 1, our product will increase by 3. And that was the product that we were looking for. We were looking for the product -2 times -3 is 6. Okay, so this is how we use a pattern. So we can just see that, well, we know what happens when we do positive values times a negative number. We know what happens when we multiply by 1 and when we multiply by 0. So we can just extend that pattern down into multiplying negatives by negatives. And so this is just another way we can see, using a pattern instead of a model, that -2 times -3 is 6. And that's great. So we can use these models and these patterns whenever we're just trying to find the product of two negative numbers. But what we know is we know that -1 times -1 is 1, right? This is something that we know. We use it all the time. You can say this in words just as if you have two negatives, then they cancel each other out. And we know that intuitively, but let's try and prove that's true using a mathematical proof. So mathematical proofs are something that you may have seen in high school geometry is where most people see them for the first time. When you see them in high school geometry, you see them in a lot of things with angles where you write a proof table where you have reasons like this follows from the side angle side relationship and things like that, if that's familiar to you at all. So let's see if we can prove this just using all the properties that we know. So proofs follow from properties and relationships that we know. In geometry, it was things like the side angle side relationship. But here we have all of these other things we can use. So the goal of this is to show that -1 times -1 is just +1. So we're going to look at, the product -1 times -1, and we want this product to be 1. So we're going to assume that it is. And if this product is 1, then the additive inverse of this product is -1, because we know that the additive inverse of 1 is -1. And if this product is equal to -1, then it should have the same additive inverse. And so that tells us, remember that additive inverses are things that sum to 0. So that tells us that if we add this product plus -1, we should get 0. If all of this is true, then this is a true statement. Okay, so we want to use some algebraic manipulation to show that -1 times -1 plus -1 is 0, which will tell us that -1 times -1 has the additive inverse -1 and is in fact equal to 1. So we want to rearrange this. So the first thing we're going to do is we know that 1 times anything is that same thing because 1 is the multiplicative identity. So that's the first thing that we do is I can just add a 1 anywhere as a factor in a product and it's still the same, right? So we added in this red 1 because we know that 1 times anything just has the same value. Okay, so we use the multiplicative identity here. And then what we do is we want to distribute. So we see that we have a shared factor of -1 in both of these products. So what we can do is we can factor out this -1 or use reverse distribution is what some people call it. So it's either reverse distribution / factoring, right? We factor out a -1. When we do that, we get -1 times the 2 remaining values, where the remaining values here were, well, I'll underline them in black, this -1 and this 1, right? We factored out the blue and we're left with what we have underlined here in black. Okay, so now we have -1 times -1 plus 1 because we factored this out. But now we can actually do this addition that's here in these brackets. And we know that -1 and 1 are additive inverses. So we, because they're additive inverses. And then lastly, we can use the zero product property to say that the product of anything times 0 is just 0. And so we've done it. We've shown that -1 times -1 plus -1 is equal to 0. And you'll notice that whenever we did this proof, that we did not use that -1 times -1 equals 1, since this is what we are trying to show. Right, and so this is the thing that we're questioning. So we know this now, but we wanted to see if we could prove that it was true. So this is, you can think about it as this is the thing that we're questioning here in this proof, is this a true statement? And you can't assume that the thing is true and then use it to prove that it's true, because that is just kind of an endless cycle that doesn't get you anywhere. If you can't, for example, if you're trying to prove to someone that the sky is blue, just saying that the sky is blue doesn't prove that it's true. You're just saying that it is. Okay, so where does this get us? So this tells us that -1 times -1 plus -1 is 0 is a true statement, which tells us that -1 times -1 is the additive inverse of 1, or the additive inverse of -1, and this product is 1. And so this can help us with our products of negative numbers. So from here, we can think of the product -2 times -3. Well, we can just think of any negative number as -1 times that number. So we can split the 2 and the 3 like so. And then we can use the associative and commutative properties of multiplication to rearrange this product and put the -1s in front and the 2 and the 3 as our second factor. Meaning that anytime we multiply with negative numbers, we can just pull out the sign and consider the signs separately than the numbers that we're actually multiplying. So you consider the sign separately and then the actual number you get. And then we know that -1 times -1 is 1, and 2 times 3 is 6. So this is just 1 times 6, 1 times 6, which is just 6, which is what we expected in the first place. So this may have been a little bit confusing to you because you are likely not used to seeing proofs that look like this, but think about it a few times. If you want to go through and understand it, go through and try and see if you can understand all of the equalities first, and then go through and see if you can understand all of the reasons for those things, and then see what it means in context. So you may have to go through this proof a couple times to understand what it means, but I don't expect you to be able to recreate this or do something like this on your own. I just wanted to show you that this is why it's true, and this is stuff you can do with everything that you know, and that's really, really cool that you know enough just about properties of numbers that you can prove these things that you may question if you haven't seen a proof of them before. So everything we've done in this class builds on itself a lot, and everything you've done so far has built to where you can prove that the negatives cancel using this really rigorous mathematical proof that is undisputable. This is a fact. Once you have this and everything's true, nobody can tell you that you're wrong because you're not. So that's just a really cool thing. And if you ever have felt like this class hasn't benefited you in any way or is kind of pointless, I think that this is something to really be proud of, that you can understand what's going on here, because this is something that even some math majors don't understand. And you should just be really proud that in this sophomore level math class, you can do something that's this complicated. So that's all that I have to say about using the sign model, the patterns, and the proofs to look at multiplying and dividing integers. So that's all for this video.